Good morning, students. The next topic, the next factor which we are going to read, which affect the rate of this chemical reaction or speed of the chemical reaction is catalyst. So we will read catalyst in all papers in paper number 1, paper number 2 and paper number 4 so that this topic will be completed. So concentrate yourself. We are going to start. A catalyst is a chemical substance which alters the speed of the reaction without itself being chemically changed at the end of the reaction. So this is the definition of the catalyst, which actually alters the speed of the reaction. So this is a figure which actually shows the function of a catalyst. So suppose in the beginning the cars have to overcome this obstacle to go to the other side of the other side of the hill. So the cars only with powerful engines were able to overcome this hurdle, but catalyst actually provide them an alternative route with lesser activation energy. So activation energy is actually the level of the energy that is required to overcome the hurdle to make the products or to make the successful collisions. So actually this was the original path that requires the higher energy, but the catalyst actually provide them means the reactants. So provide reactants an alternative route which requires lesser energy. So lesser activation energy is required now. So more cars will be able to cross this hurdle now. So this is the function of the catalyst, which is shown by the figure. So look now, a catalyst speeds up a chemical reaction by providing an alternative reaction mechanism with a lower activation energy so as to produce more effective collisions per unit time. Catalysts have a surface on which reactants can settle. So this is now the process how catalysts provide them a new ground to come and play. So look now, catalysts have a surface on which reactants can settle and join together. The catalyst increases the chance of the particles meeting and so increases the rate of the reaction. So definitely catalyst increases the chance of the particles meeting. So when they meet more, there will be more chances of the successful collisions. Once the particles have met and joined together, they move away from the surface of the catalyst. This leaves room for the other particles to join together. And this process is repeated again and again. So reactants come to the surface of the catalyst, join together and move away. Then new reactant particles come, join together and move away. So actually catalyst provide them a surface to join together. So actually their meeting chances increases. Higher temperature and surface areas make them more effective. So these are the conditions for catalyst to effect more. So look now, high temperature and surface areas make them more effective. The function of the catalyst are shown by another figure. So look now, here are the reactants, here are the products. In the beginning, this path was required to overcome. Look at this path, the higher level of the energy is required. So the particles only with higher energy were able to overcome the activation energy to transform into the products, but more of the particles were unable. So it means the reaction speed will be very slow. Only the strong particles were able, lesser strong will be unable. So but the catalyst now, so look now, this was the original path, uncatalyzed reaction path, but this lower path is called catalyzed reaction pathway. So when we add some kind of the catalyst that is suitable for the reaction, the catalyst provide them an alternative route with lesser activation energy. So this path is created now. So now more reactant particles will be able to overcome the activation energy. So products will be formed quickly and reaction will be completed quickly. Different reactions need different types of the catalyst. Transition metals and their compounds make good catalyst. Enzymes are biological catalyst. A catalyst does not change the amount of the product formed from the reaction. So this is an other point to understand. The amount of the products will be same with the presence of the catalyst or without the presence of the catalyst. The only difference will be time. So in the presence of the suitable catalyst, less time will be taken to complete the process, and in the absence of the catalyst, more time will be taken for the reaction to be completed. Okay, here is another very important point. Remember students, some reactions need to be accelerated because originally they are very slow. But at the same time, there are some reactions which are very speedy. So observations are hard to be observed. So those reactions need to be slowed or decelerate. So it means we need two kinds of the catalyst. The catalyst which can accelerate the speed of the reaction, or some reactions need to be decelerate. So there should be some catalyst which actually decelerate the speed of the reaction. So this point is going to read now. Positive catalysts increase the reaction rates by lowering the activation energy, like in this figure. Some catalysts decrease the reaction rates by increasing the activation energy. So they actually create a path with higher activation energy so that the reaction speed can be decreased to make some observations. These types of the catalysts are called negative catalyst or inhibitors. So the catalyst which increases the speed of the reaction are called positive catalyst, and the catalyst which decreases the speed of the reaction are called negative catalyst, or another special name inhibitor is also used for them. Here is another very important point to be noted: homogeneous catalyst. So if the physical state of the catalyst and the reactants are same, so both are maybe in liquid or both may be in solid. So if the physical state is same, then they will be called homogeneous. And if the physical state is different, then those kind of the catalysts will be called heterogeneous. So look now, homogeneous catalysts are those having the same physical state as the reactants. For example, chlorine catalyzes the decomposition of the nitrogen oxide. So it means reactant and the catalyst both are in gaseous state. So that's why catalyst is called homogeneous catalyst. On the other hand, the physical state of the heterogeneous catalyst is different from that of the reactants. Okay, here is an example which we are going to read. Hydrogen peroxide decomposes very slowly in aqueous solution, and the reaction is 2H2O forms 2H2O plus 2H2O plus O2. Okay, this reaction is actually in the beginning without the presence of the catalyst. Manganese oxide is particularly good catalyst for the above reaction. When it is added to the hydrogen peroxide, oxygen is produced with vigorous effervescence. So this is manganese dioxide, that is actually a catalyst which can accelerate the reaction speed. Okay, so this is the example. Okay, now we are going to read an experiment which is particularly concerned with the paper number 4, alternate to practical. So what catalyst actually create, what kind of the effect catalyst produces on the speed of the reaction? So look now, experiment is, reaction is, so hydrogen peroxide is producing water and oxygen. So catalyst in this reaction is manganese oxide. Manganese oxide catalyzes the decomposition of the hydrogen peroxide into water and oxygen. So we will conduct two types of the experiments with same conditions. The only difference will be the catalyst. So look now, 50 centimeter cube of 0.05 molarity of H2O2. So look now, the same thing is taken in the second experiment. In the first experiment, no catalyst is present, but in the second experiment, 0.10 grams of manganese oxide is present as a catalyst. Room temperature is there for both types of the experiment. So conditions are same except the catalyst. So it means now we are going to observe the effect of the catalyst on the rate of the speed of the reaction. So look now, this will be the setup in which H2O2 will be placed and some manganese oxide will be put into the beaker. So interpretation of the data. So look now, a graph of the volume of oxygen gas given off against time. So a graph will be plotted, time against the volume of the O2 produced. So look now how O2 produced can be observed. When O2 will be produced, that will go into the syringe. So more the O2 will be produced, it will push the plunger to the right. So from here we can observe, we can note the volume of the O2 produced with time. A stopwatch will be used at the same time. For example, after 10 seconds we will note the volume. After 50 seconds we will again note the volume, and up to so on. So a graph will be plotted of the values for the experiment in presence of the manganese oxide. So look now, here are two graphs on the same sheet of the graph paper are produced. A graph of the volume of the oxygen gas given off against time is plotted. So time is taken on the x-axis and volume on the y-axis. Same amount of the hydrogen peroxide is used in both experiments. Hence, the same volume of the oxygen is collected in both experiments. The speed of the reaction is higher in experiment 2. So this second curve number 2, is actually in the presence of the is an experiment in the presence of the catalyst. So the speed of the reaction is higher in experiment 2 because the reaction took a shorter time to complete. The gradient to the curve at time t is equal to 0 is steeper. So actually the steepness of the curve shows the rate of the reaction. More is the steepness of the curve, more will be the rate of the reaction. Less will be the steepness of the curve, as in curve 1, less is the steepness. So that shows less, slower will be the rate of the reaction. Okay, some more things in catalyst are also going to be read. So look now, examples of the catalyst used in the industry. So this small question may also come in the paper and has come many times in the paper. So look now, platinum aids the oxidation of the ammonia in the manufacture of the nitric acid. So these are some kinds of the catalysts which are used in the industry. Vanadium oxide is used in the contact process of manufacturing sulfuric acid. Finely divided iron promoted with alumina and potassium oxide is used in the Haber process for the manufacture of the ammonia. Nickel is used in the hydrogenation of unsaturated fats, for example in making margarine. And silica, aluminium or platinum catalysts are used in cracking and reforming the fractions of the crude oil. So you have to learn 3-4 catalysts. this question normally frequently come in the paper. The next thing which we are going to read is, note that there are some catalysts that actually hinders a chemical reaction. The ones that speed up the reaction are called positive catalyst, that lowers the activation energy. And on the other hand, the negative catalyst actually increase the activation energy and hence slow down the reaction. They are known as inhibitors. Okay, next thing which we are going to read in catalyst are catalytic converters. European regulations state that all new cars have to be fitted with catalytic converters as part of their exhaust system. So this small question also has come many times in the past papers. So catalytic converters. Car exhaust fumes contain pollutant gases such as carbon monoxide and nitrogen monoxide. So when fuel burns in the vehicles, carbon monoxide and nitrogen monoxide gases are produced, which are poisonous, which are dangerous for the health of the living beings. The following reactions proceed of their own accord, but very slowly under the conditions inside an exhaust. So carbon monoxide plus oxygen forms carbon dioxide, and nitrogen monoxide with further addition of the oxygen forms carbon dioxide. So this is the function of the catalytic converter used in the modern cars. They produce carbon dioxide and nitrogen, which are already present in the environment and which are less dangerous as compared to carbon monoxide and nitrogen monoxide. So this is the function of using catalytic converters in the modern vehicles. The catalyst in the converter speeds up this reaction considerably. In these reactions, the pollutants are converted to carbon dioxide and nitrogen, which are naturally present in the air. It should be noted, however, that the catalytic converter can only be used with unleaded petrol. So this is the condition. So catalytic converters required unleaded petrol, and that due to impurities being deposited on the surface of the catalyst, it becomes poisoned and has to be replaced every 5 to 6 years. Okay, the final very small topic in the catalyst is enzymes. Enzymes are protein molecules produced in living cells. These substances are used by living organisms as catalysts to speed up hundreds of different chemical reactions going on inside our body. So some catalysts are produced naturally in our body that actually speed up some chemical reactions. Biological washing powders contain enzymes to break down stains such as sweat, blood, and egg, and they do this at the relatively low temperature of 40 degrees C. This reduces energy cost because the washing water does not need to be heated as much. So this is the advantage of using a washing powder that contain a catalyst, because the catalyst actually removes the stains of the blood and etc. at even lower temperature. Otherwise, we have to warm the water to clean the stains on the clothes. So this is the function of the biological washing powders. So this was the topic, students. Read this lecture again and make your notes.